Hi and welcome. So this time around I've got a quick project here which is to add a DRO to my surface grinder, because a lot of times you will pull the wheel up and you'll make a lot of revolutions of the wheel, not remember to count them, and then want to return where you were and have a hard time doing it. So it'll help me with that. I did not get a name brand DRO system because they are really expensive, like over $2,000. So I found this one in China, and this one's 2-axis, and I got 1 micron scales. So that is less than, it's like 2/10,000ths of an inch per. So we should be plenty good resolution wise if it actually works out. So now I just got to figure out a mounting scheme that'll be rigid enough to actually report back the 2/10,000ths without just flexion becoming a problem. Originally, I was going to try and use these set screw holes. There's set screws buried in there, but they didn't thread the outer portion of it, and so there's a large portion I can't use. The blue tape represents a rib inside of this unit that is about 1 inch wide and sticks out about 1 inch deep. That's just a reinforcing rib that goes down. I could use those holes, but I think I might want the scale closer to the front. So I still haven't figured out exactly where I want the scale on the side, although I'm pretty sure I don't want the scales on this side because debris from the surface grinder tends to go this direction when you're dressing the wheel. So it tends to spray everywhere, as you can tell. Even though I keep it pretty clean and clean it, you still have debris everywhere. So I don't think I want the scales on this side. Also, for the y-axis, if this one's the x-axis, this one being the y-axis, the y-axis scale, this is where it locks off the y-axis. So I don't think I want to put it over here. It's already too busy, too much stuff. So I think we're going to shoot for this guy right here. See if we can mount the y scale right here and attach the base over here, or the sliding part, fix it here, and actually have the scale move and the sliding part be fixed. The next step was to take the y-axis, put some tape here, move it to its extremes. The blue lines relative to this line back here show the range of motion, which show the 8 inches or so of travel. Then I did the same with the z-axis, and holy cow, was that pain in the butt. My arms are burning because the z-axis has an 18-inch travel roughly, and that is a lot of revolutions of this dial, which I think is something like 50 thousandths or something like that, or maybe 100 thousandths. It's crazy. Anyways, so we found the range. That shows me where my scales physically need to be mounted in order to cover the range. So next up, figuring out how to mount it. Interesting bit on the scales is they come with this plastic shim here, which spaces them exactly the right distance above the base unit here. So you can leave that in when you're trying to plan your holes. It just slides right out. It's just sitting there. Pretty cool design, actually. So I think we're going to shoot for mounting the scale all the way up, and we're going to need to space it out a little from the side here so that it doesn't rub. And we're just going to put a couple holes and drill and tap with some spacers, maybe 1/2 inch out. And then we'll make a cross piece over here to meet up with it. That's the z-axis. The y-axis down here, we're just going to put the scale up here, mount it up high, and we're also going to have to put some spacers here to space it out, and make a bracket to attach it to the base unit here. And I think we should be good. Next, I'm going to relieve the spacer block for the z-axis, because the protective cover on the motor cover doesn't go perfectly straight up and down. It looks like it's sheet metal work, and they didn't do a perfect job on it. So we're just going to relieve some material. Going to use this zircon nitride coated cutter, and we're going to go down about 1/8 of an inch in about 5/8, roughly. This is going to make quite a mess. We're just going to leave a little bit of stick out. We're going to go and do 6-8 inches at a time, and then we're going to come back and slide the bar, and continue. Now the name of the game is loosen the vise and slide this guy over to continue the cut. By the way, I dropped the table about 10 thousandths of an inch so that I wouldn't have to worry about dragging on the cutter. And another thing, if I hadn't been lazy, I could have taken the vise off of the table, clamped this to the table, and done it in one go. But I really didn't want to because I was lazy. So anyways, we're going to continue along. It's going to take 3 total passes, and I'll bring you back when I'm done. Next up, we're going to drill some holes with the side with the most meat. We're going to drill, and then we're going to countersink because we want these guys to sit just below the surface. Alrighty. Okay, 0.175, and it sits below the surface. Very good. Now, as far as positioning these holes, I locked off my y-axis this direction so that they'll all be in line, but I'm not being particularly careful. I did mark out with a rule where they're going to end up, but we're not trying to be super precise about it because I'm going to use these holes to drill the ones into the machine itself. They're 5 inches from the edge and in the center. There we go. That'll work. Off camera, I also finished the smaller scale. I've got to deburr this side with countersink, same thing. Next up, we're going to drill and tap for the mounting screws for the scales themselves. These other counter recess screws are the ones that mount the spacer to the base, and then these mount the scale to the spacer. So I've marked using the spacer, using the scale. I've marked the inside of it, and you know what, let me show you the pen I used. If you haven't seen one of these before, these are fast cap markers. They have a really thick side for marking broad stuff, and then they have this fine side that can reach into really small holes and mark out a position. Very handy to have. Company fast cap, if you can see that. Yeah, focus. There you are. The countersinking is just to make the entrance of the tap easier. And since this is a through hole, I've got a spiral point tap, which will push the chips ahead of it. All right, 1 down, 3 more to go. I'll bring you back. So you can see here I've drilled and tapped the iron casting and screwed in the spacer plate, and now I'm going to mount the scale, and that'll let me find the location of the other mounting piece that's going to control the slide. Okay, so we have the top part of the scales mounted on the bottom for the y-axis as well as the z-axis, and we are going to have to take an indicator along this and get this as square as possible, because if it's at an angle, then obviously the distance is going to change by the hypotenuse, and we don't want that. So we will take an indicator and get it pretty darn square, and then we will figure out how to make a mount for this guy, which is going to connect to that on this part. and the mount between this and the base here. Next up, I've marked out, I've loosely attached the bracket to the traveling sensor and marked out the insides. And there's almost no force on this, so I'm going to start with 2 screws and see how that works. And then if we need more, we'll add more. So these are loose, so this can be held flush. And anyways, they got the nice little spacer in here that keeps this space the appropriate distance from the glass scale or the magnetic scale. I'm not sure which one this is. So we're just going to drill, tap, and test it out. All right, a couple screws appears to be more than plenty, and I will dress the cable in after I'm done with both cables, and I've mounted the final the display so that I know where it's going to go. I can pull the spacer out, although it looks like it wants to come out a little bit better when it's away. So looks like there's a little bit of an angle. I might need to adjust these bottom 2 to fix that here, which I will do in just a second. And anyways, I will be right back with the next part, where we put the same one, build the same sort of part for the column, although it's a little more complicated. So we're working on the bracket for the sensor here that mounts on the arm, and I'm going to use the existing holes as I mentioned before. There's more up here, and I believe those were all for the auto dresser that you could buy as an option, which I did not get. So I am going to have to weld some pieces together, but what I'm first doing is I'm making a bar that will extend out here. It's hollow, and it'll mount on these 2 holes. I am going to slot them so that I can get everything positioned, because this is kind of spring-loaded, so it makes it hard to set up for an exact distance. So we're going to put some really short slots in them, and then I'm going to weld on a bracket that came with this that mounts to these holes here, also slotted, so everything can be positioned just right. So let's head over to the mill and work on that. To locate these holes, I put some set screws in there and measured across them to find the X distance here, and subtracted the diameter of 1, and that gave me the space between centers, and that's 1.650. And then to get the position in this direction, which was a little more challenging, I put some set screws in there, put some Dykem on here, and saw where the scratch marks slide, and one of them was really nice on this line. That's why we're going to do some slots, because you can see this one's a little bit above the line, that scratch mark. So what I could have done is taken the set screws and made a holder for them that I could turn the lathe, turn a point on them so that I could actually find this more precisely. But since I'm going to do slots, it doesn't matter. If you think the 1/8 wall tubing's overkill, I'm actually trying to make a very rigid setup. I was considering using solid originally, which would have been in the overkill category even more, because we're trying to measure tenths here, so everything needs to be really stiff. So if this one ends up not working out, I will make one out of solid to compensate. So now we're going to do something that's a little bit risky. I'm going to mill the top for 1/4 inch, and it should just line up nicely, which it does. And I'm going to go back and forth here, and then I've got the end mill sticking way out, and the shank is a 1/4 inch too. Then we're going to go down to the bottom, and we are going to try and just machine the bottom next. So cross my fingers, hope this works. There's the squealing already. Got to be gentle or I will snap this guy. As long as I'm at it, here's one more technique which I should have been using actually. I just didn't think of it. I forgot about it. So instead of side milling, putting all the force towards the side of the end mill trying to break it by trying to cut a slot, you can take chunks out of it instead. So you can move over a chunk, and I'll show you what I mean here. So here we are. We'll slide over about 50 thousandths, why not? And we'll just cut down and cut over another 50 thousandths and cut down, and another 50 thousandths and cut down. This takes a lot less force on the end mill, or puts a lot less force on the end mill. And it's a really great technique, and I could have done it down below where I'm really relying on the stick out. And you don't get the squealing either, which is really nice. All right, I got everything loosely attached here, and I'm going to mark off the points on this plate here that I want to weld. And I left extra material back here so that the weld bead would minimally distort these grooves. So I'm just going to have to set down the camera to do that. But anyways, those 3 bolts are pretty loose, and they can go back and forth so I can get this parallel to the face of this, or perpendicular to the side, and make the motion linear and along a parallel line rather than some sort of hypotenuse, which would be bad. Alrighty, so here is the unit in place, and I know my welding is terrible. I don't practice very often, and so I am very, very rusty. If I spend like a day at it, by the end of the day, they start looking somewhat passable, but it's been quite a while. So we can pull the spacer out of here, and now you'll notice that there is the prescribed gap that the manufacturer recommends, and we are good to go. So now we just got to figure out how to mount the arm for the readout and dress the cables. All right, so final install here. I couldn't figure out any way to get the shields to fit over this adequately, so I'm not really using those. Fortunately, dust is all going that way, so hopefully that won't be a problem. I did put the scales on the right side specifically to be away from dust from dressing, although dust does seem to get anywhere, but there's no easy way to get the guard to fit over this. And it would really need to come from this side, which it can't, so that's sort of pointless. Same on the bottom. There wasn't really a place for it. I probably could have done a better job on that one and made it fit a little bit, but not much dust gets down there. That stayed clean the whole time. So here we are, and here is me moving approximately 1/1000th by the wheel. And that's 9.5 tenths, which would be just 1/2 tenth under 1/1000th. All right, so here's the hand wheel with the lash taken out. We're right on 0. We've got our 50 millionths indicator right on 0. I bought this used, never had it calibrated, so I don't know if I can exactly trust it to the 50 millionths, but we'll give it a shot. And we've zeroed up there. The x-axis is the z-axis. Let's dial them 1/1000, see how they compare. All right, so there is the 1/1000th. It looks like we're just a smidge over the 1/1000th line on the wheel. We are just a smidge over the 1/1000th line there. And we're just a smidge over the 1/1000th line here by 20 millionths. Now, this guy reads in increments of 40 millionths, I think. 20 millionths. I think it is 20 millionths. So that's the lowest value it can read. All right, let's dial another 1/1000th. All right, at 2/1000ths, it looks like it's almost dead on the line. That's good. Here we are pretty much right on the line. And up here, we're 50 millionths. So we're 1/2 tenth off. So, you know, this stuff's all so persnickety, I could easily see that being taken up in slop. It's pretty tough when you're dealing with things like this. Just even temperature differentials, everything comes into play. I'm not incredibly experienced at dealing with precision like this, so this is an interesting experiment. So I went up to 4/1000ths using the indicator. The wheel says we're under by about 1/10 or so. The indicator here is right on, although again I said this is not a calibrated indicator, and the DRO is reading 1.4 tenths under, which kind of jives with the hand wheel here. So Maybe this indicator needs to be sent in for calibration. Not entirely sure, but interesting experiment. Anyways, it's plenty accurate for everything I do. We'll work on more precision when I understand all the factors that go into it a little better. And we double check the y-axis, which is this direction, and that's great as well. So we're good to go. All in all, the DRO installation I think was a very successful project. Hope you find it useful. Thanks for watching. Hope to see you next time.